All right. Hello, everyone. Thank you for joining us today from different parts of the world. Welcome to Pcloudy's webinar on Your App is Your Bank Practical AI Testing Strategies for Flawless Digital Experiences. We're thrilled to have you with us today. I'm Geraldine, and I'll be your host for today's webinar. So, before we dive in, let's cover a few housekeeping details. Your lines are currently muted to ensure a smooth experience. However, we encourage you to ask questions, so you can submit them using the Q&A option that you see at the bottom of your screen, and we'll address them during the Q&A session that at the end of the webinar. And also note that this webinar is being recorded, and we'll be sharing the recording link after the webinar. So feel free to share the link with your colleagues or peers who might find this webinar valuable. And now let me introduce our speakers for today, George Ukru and Jessica Selvin. First up, we have George, who's an expert technologist with over 24 years of experience across test engineering, product management, and user experience. He currently serves as the general manager at McLaren Strategic Solutions, where he drives cutting edge initiatives in software testing, automation, and AI driven quality assurance. George is widely recognized as a thought leader in the testing and automation space. He's a LinkedIn top voice, a frequent speaker at global industry events, and the host of the popular podcast Automation Hangout. Over the years, he's helped numerous organizations across industries enhance their QA maturity, accelerate release cycles, and implement scalable AI powered testing solutions that drive real business outcomes. And we also have Jessica, who is a pre sales specialist at Pcloudy with over 5 years of experience in the IT industry. She specializes in test automation, AI driven testing strategies, and continuous testing methodologies. With her expertise in modern testing frameworks, DevOps integration, and AI powered test optimization, she's helped numerous organizations optimize their testing processes. So, without any further ado, let's welcome George and Jessica. And George, over to you to take this webinar forward.
Yep. Thank you, Jerulin, and good morning and good evening to everyone. So we are primarily going to look at, I would say, a couple of use cases around AI, specifically focusing on the digital banking. So we'll actually get started by looking at some of the interesting trends that we have seen in the digital banking side. So if you look at the overall banking industry in the last couple of years, there has been a significant shift where customers are more comfortable using digital banking channels compared with maybe an in-branch kind of a visit. And I would say three-fourths of the customers that any bank is having are actually using digital banking currently. And due to this, there's a lot of focus on the banking side to actually bring in innovation as well as transformation to the digital banking channels so that you provide a better experience as well as generate additional revenue and profits. So let's take a look at some of the maybe the top 7 trends around digital banking. So there has been a huge, I would say, adoption of agile across industries, and banking is not, I would say, different. So most of the banks have decided to go with the agile model of development, and you're primarily having either a 3 or 4 week sprint in which products are actually getting released into production. And this is actually helping banks to actually meet the regulatory compliance, as well as they're also able to provide additional features or new features to their customers. But from a testing side, this actually puts in a lot of pressure on testers because this is you're actually going to get very less time for your test design, test planning, and test execution activities. Now, there's a lot of focus around, I would say, hyper personalization, which means that you're looking at the customer usage patterns, behaviors, age groups, lifestyle, purchase patterns, and all of those things. And you're primarily using AI and analytics to actually push customized offers to customers. So, customized offers can be in the form of a home loan, a credit card, or it can be a personal loan, depending on the analytics and the AI output. Now, in today's world, in digital banking, you actually have numerous channels through which you can actually bank. ATMs, you have kiosks, you basically have internet banking as well as mobile banking. And it's very important to actually provide a unified experience across all these channels. And it's also important to make sure that where to look at scenarios like where the customer starts a transaction, maybe an internet banking application, and then maybe ends it maybe on a mobile app. So there should be a smooth transition between channels as well as the unified experience across channels is also very important. from a banking standpoint. There are a lot of frauds and a lot of hacking and other things happening on banking websites, due to which there's a heavy focus around security. So the current policy of bank is something like never trust, always verify. That means like they're very cautious in actually onboarding customers. They also do a lot of verifications for every transaction that you do. So security is also having a very big impact around digital banking, and banks are also heavily investing on the security and other related activities. The cloud has actually been considered as, I would say, banks have become open towards cloud adoption. You can actually see that many of the banking solutions are now moving into the cloud, and primary reason is to achieve more scalability as well as reliability. And there's also a focus around continuous monitoring, which is nothing but looking at what your users are doing in production. It can be, I would say, monitoring the performance of an application, monitoring health of an application, or even monitoring customer feedback in real time, and this data is continuously used to proactively solve issues as well as define new strategies for what I would say rolling out applications. The last but not the least is around AI driven development or AI driven solutions. So you can actually see a numerous amount of solutions that are AI based being used inside a bank, starting from maybe a chatbot or a virtual assistant with whom you may be actually what I would say doing conversation to solve your tickets, or it can be an AI model that is being used by banks maybe to issue loans, or maybe to detect what I would say fraud related transactions. So there are numerous, I would say, like a lot of investments that have gone into in banks to actually implement AI, and you can also see that see that this is actually going to increase in the next couple of years as well. So these are some of the common trends that you see among within the digital banks across the globe, but the expectations and the expectations are very high, and there's a lot of transformation happening in the digital banking side. But at the same time, when you look from a software testing angle, there are a lot of challenges that a tester or maybe anyone working in a testing group, it can be a test manager or a test architect, there are day-to-day challenges that we may have to deal with, especially when it comes to banking. One is basically there is a high pressure on banks to actually comply with regulatory requirements. So that's the reason why they've adopted agile. So it's almost important to actually it's very important from a testing standpoint to ensure that the releases are actually happening on time. But many times the testers or the testing team is slow in providing feedback to the development team. And what happens over a period of time is like you may actually miss on your deadlines or your release schedules, because you are actually giving the defects or reporting defects maybe in the last week of the sprint, and the developers may not get enough time to solve them, and finally your release may not happen on time. Test coverage and quality seems continues to be a challenge, especially with highly critical applications or modules or capabilities like payments, as well as I would say like money transfer. So the coverage is slow, and the quality is also sometimes very concerning with digital channels. Since you actually have releases happening every week or every month, the amount of changes that happens to the user interface is very high, and due to which even if you have a good automation coverage, you may actually end up with a lot of test case failures when you're trying to run these regression packs as part of your regression cycles. There's a lot of data that is being collected, both from a software engineering standpoint as well as from the customer. But very rarely we have seen testing teams utilizing this data to improve the way testing is done. So it can be maybe production defects, or it can be production tickets, or maybe feedback that is actually coming up in social media forums like Twitter. Testers do not pay a lot of attention towards this kind of feedback, and it is very rarely used to improve the way in which testing is currently being performed. Even though applications have moved to the cloud or are moving to the cloud, performance seems to be a concern. There has been improvement in the area around performance. You rarely see banking sites coming down, but you can notice that there are time periods where you actually see slowness in both your mobile banking as well as with your internet banking application. So security seems to be the performance seems to be a concern, and there's not enough attention that is being paid to performance as well as non-functional testing in many of the banks. Since what I would say, like you're working in agile mode, hardly get, I would say, a couple of days or a couple of hours to actually complete your test design, due to which you may actually end up writing low quality test cases. And moreover, you may be under heavy pressure to complete your test cases before the first build is given to the testing team. There is no way in which you can actually find out how good is your coverage, unless you're actually using maybe a sophisticated tool or an AI-based tool. So in many organizations, the regression coverage as well as the overall functional coverage is not known because it is very difficult to find out what amount of coverage is being offered by the test cases that are already there. And last point is around inclusiveness. There are a good amount of, I would say, folks who are differently able, who are digital banking users. But I don't think even now we have enough focus around this area of accessibility. So accessibility and inclusiveness seems to be a concern with banks, and this is seriously impacting their revenue as well as the user satisfaction. So these are some of the challenges that you see which are related to software testing within banks. Some of them may be across industries, but there are maybe very specific challenges like quality as well as performance, which may highly impact the performance of a digital bank. Now let's likely look at how is that we can use artificial intelligence, or how does artificial intelligence help a software tester. One is definitely productivity. Software testers can be more productive if by using AI-based solutions. The productivity improvements can come in terms of test case design, test case execution, or test maintenance. We'll see that in detail on how it actually provides you productivity improvements in the subsequent slides. Similar to productivity improvements, the next area where testers can actually see benefit with AI is improving the speed of testing. So improving the speed of testing is primarily by maybe you can actually cut short your test execution cycle, maybe by using AI. You can actually select the test cases that are of high importance and execute them. Or you may actually use AI to actually shortlist test cases that have the highest probability of finding defects. So AI can definitely help you to save a lot of time in across various activities in the testing lifecycle. You can also use AI to actually take decisions. As I was mentioning earlier, there is a wealth of data that is actually collected, both from the customer as well as from the what I would say from the software engineering standpoint, which is very rarely used to generate insights. But you can actually use predictive analytics and other solutions, AI-based solutions, in order to generate insights, which can actually help you take decisions. And AI can also help you to actually shift left your testing. There are many ways in which you can actually carry out testing much early in the life cycle with the help of AI. And this also can actually help you to reduce the overall cost associated with rework. A simple example can be maybe finding out maybe regression defects early in the life cycle, maybe by doing a targeted regression based on code impact. That can be a good solution that can actually help you to find regression defects maybe the first week of your sprint. There's always a focus on user experience, and AI also can actually help you to improve the experience. Visual testing, or maybe verifying the visual components of an application, is a good example where uh, uh, where you can actually improve the overall experience that is provided to the customer. Or it can be an AI-based solution that can be used to analyze customer feedback that which can be used to improve the way testing is done. So there are numerous ways in which AI can be used in order to improve the customer experience. Finally, you can also look at the operational overheads. There are a lot of companies where we have seen test reports being prepared manually. There's a lot of dependency on maybe infrastructure team to provision data. So a lot of self-service kind of solutions can be implemented, like a chatbot, which can actually provide you test reports or maybe insights around what's happening with your release. Those kind of solutions which are self-service can also reduce a lot of manual activities or overheads that are associated with reporting, as well as some of these can be related to administrative type of work as well. So these are some of the way these are some of the what I would say benefits that a tester would actually get, or a testing team would actually get, by implementing an AI-based solution. And definitely, I would say in the last 3 years, the maturity of AI solutions have increased. Previously, we were actually creating custom models and other solutions to implement anything around AI. With OpenAI, Deep Search, and other models being in place, there are a lot of products and I would say solutions that have come into the market that actually has AI capabilities. And the maturity of these solutions have also increased significantly in the last couple of years. So it's very important to look at AI very seriously now, even though it has not reached a state where it can take away testing jobs. Definitely, it is actually, I would say, organizations who have implemented AI, they are really seeing the benefits. It can be, I would say, in terms of cost savings, effort savings, or in terms of quality. Now, let's take a look at some of the common use cases or some of the top use cases around AI. You can actually use AI to actually analyze user stories. You can actually use AI to generate test cases. You can actually do an impact analysis to find out areas of your application that needs to be tested. You can use AI to actually reduce your test maintenance overhead by implementing self-healing. You can use visual testing to verify the visual components of your application, as well as to make sure that your application behavior is consistent across different devices, browsers, as well as resolutions. You can use coding assistants, which is something new that came into the market a couple of years back. Coding assistants is another AI solution that you can use in order to improve your productivity around test automation. You also have test observability, which is mostly, I would say, shift right testing technique, which actually helps you to ensure that your application is continuously available in production. And then you can also use AI for test orchestration, primarily to execute a large number of test cases in a minimal amount of time. So these are some of the use cases. If you look at the complete list, I would say there can be around 30 to 40 different use cases that you can think about from an AI standpoint. And I would say, like, if you're actually planning to implement AI in your organization, you can actually look at your current challenges and then maybe decide what kind of solutions may actually help. You're just giving you a sample, what I would say, a very short list of use cases. In the interest of time, what you've done is you've actually shortlisted around 5 use cases from what we explained. So the first use case that you would like to take up is basically smart user story analysis. So requirements or user stories. The requirements no longer exist because every organization has moved to agile. It's primarily user stories is what you see in every project. And very rarely I've seen testers spending enough time in order to groom the user story or to analyze the user story to find anomalies. So what typically happens is the first week of the sprint, before the sprint grooming session or planning session happens, testers don't even open the tool and look at the user stories. The primary focus is just to do planning and some kind of estimate without even understanding the user story. And maybe the first week of the sprint, when you're supposed to write test cases, you go through your user stories and then find out there is not enough clarity around the user stories, and then you start raising clarifications with your product owner or with your business analyst, and you lose a lot of time. Your test cases may be half cooked, or you might have written your test cases already. Your developers would have already started coding. They might be doing unit testing. At that point of time, you start your business analyst or product owner may start making changes to the requirements, and then you actually end up with a lot of rework. Or in some cases, you may not even know whether the user story was good enough. When you once you implement the product, once it goes to production, based on customer feedback, you may find out that the requirement that your business analyst has given you was incomplete. But now there are multiple ways in which you can solve the problem. You can actually you can actually spend, I would say, a good amount of time analyzing the user stories manually before your grooming session, or you can actually have what I would say spend time reviewing and discussing about the user story during your grooming, which is actually, I would say, a manual activity which consumes time. And if you want to really participate in those kind of meetings or activities, you also need to have some kind of application as well as domain experience, which may not be available always, especially if you're working in the services sector. But now there are solutions which can be either custom or commercial solutions that you can leverage that can actually take user stories from a tool like Azure DevOps or Jira, and then start analyzing those user stories using any kind of industry framework. There are a lot of frameworks around user stories that are very popular. Smart, Invest, Quest are some examples, but there are many more user story frameworks that are available. You can actually use an AI-based solution to review user stories and then find out anomalies in those user stories. And you can also go one step further. You can also train these solutions with your project requirements or with your application documentation so that it actually gives you very meaningful, I would say, results. And what you can do, you can actually go ahead and once you actually have these, what I would say, anomalies, ambiguities, I would say, listed, you can either go and fix it manually with the help of your business analyst or a product owner, or you can actually use the tool itself to actually rewrite your user story as well as acceptance criteria. So if you look at the industry data, even now there are like more than 70% of the projects are actually failing because the requirements were not captured in the right manner. And you can actually get rid of this problem to a very great extent by actually using a user story, what I would say, an AI-based user story analysis, which is something that you can easily do. Maybe if you spend a couple of weeks or maybe like 2 to 3 months of time, you can even develop your own solution based on your company standards, as well as based on maybe some kind of model training that you can actually do based on your application documentation as well as domain. That is first use case. I've started using this, I would say maybe 3 years back. we developed a custom solution. And then when OpenAI came in, we started implementing this as using the APIs of OpenAI. And we've actually seen good results where you're able to detect up to 90% of the issues with respect to user stories before you actually start the sprint. And then that has actually helped us to achieve a good amount of sprint velocity as well as the commitments that we provide to the business team. The second solution is around test case generation, which is an area which is, I would say, maybe the second highest in terms of effort. Test execution, I would say, is the phase or activity that takes the highest amount of time in testing. Ideally, you spend 30 to 40% of your time in test execution, whereas you may spend around 20 to 25% of your effort in designing test cases. You definitely, the manual approaches, you review a user story, you analyze it, you basically break it down into test scenarios as well as test conditions, and then you start manually writing these test cases. And if I give a user story to two testers, you may actually get maybe different number of test cases and different number of scenarios. And it is primarily, I would say, experience based. Even though you use standard techniques, there can be differences in the quality of test cases that are actually generated by testers, and experience plays a very major role when it comes to test case design. Now, and it's actually effort intensive, as I was mentioning earlier. 25% of the effort is actually being spent on test design. But now there are a lot of ways in which you can actually automate the test design. So prior to maybe AI is becoming popular, you might have heard about model-based testing tools. Agile Designer was there. There are a couple of other tools that were available in the market that actually had this capability of maybe taking workflow diagrams and then generating test cases. And they were very good from an end-to-end testing standpoint. But now there are multiple other inputs that you can actually take in order to generate your test cases. And in some cases, there are solutions that can also generate automation scripts. One is basically if you're looking at maybe an application that is built using microservices architecture, you can actually look at, I would say, API as your input. You can actually refer to a Swagger documentation, and AI-based solutions can actually generate test cases from your API documentation. So these are very fast. API tests are very fast. They're less costly to maintain. So API can be a first target when it comes to test case generation. Or you might be working on an application that's already there, or you might be having a prototype but no requirements. You can definitely come up with a solution or design a solution that can actually look at maybe a Figma prototype and then generate test cases. Or you may have user stories that are actually groomed. You can actually feed in user stories to your test design tool, and the tool can actually give you a set of functional automation scripts or functional test cases, depending on what you need. And this also gives you what I would say, like this also helps you to what I would say achieve a lot of coverage, the optimal amount of coverage, as well as it also saves a lot of time. Or you may actually use a solution which is primarily, I would say, maybe a prompt-based solution where you actually type your requirements maybe in simple English, and the tool will actually generate an automation script or a test case based on the instructions that you provide to the tool. So there are like four or five different ways in which you can generate test cases. But most of these tools will actually have an NLP parser, a test case generation engine, a plugin that can help you to connect to a user management tool or user story management tool, as well as a formatter, which actually helps you to generate test cases in the required format. So this is, I would say, a beautiful solution that's out there. There are plenty of tools that can actually help you. Worst case, what you can do is you can actually create a custom GPT with a prompt, which can actually help you to automate this process around test case generation. And from my experience, the quality of test cases that you get from these tools is dependent on the prompt that you write, as well as the engine, if it's a commercial tool. But some of the tools that I saw, the quality of output was actually equivalent to the output that you actually get from a tester who's having maybe 2 to 3 years of experience. The next important area where AI can actually help is basically self-healing and test orchestration. I've seen organizations where there are like thousands of test cases that needs to be run. I used to work with a customer, a technology customer, who actually had around 34,000 test cases or test automation scripts that they were running on their global application. And it used to take days together to run this. Now you actually have solutions which can actually help you to do large scale execution. Most of the automation tools that you see in the market actually has a parallel execution engine that can actually help you to run multiple tests in parallel. You can actually configure the engine in such a way that you can decide upon the number of tests that you want to run in parallel. And then most of these platforms actually have an intelligent orchestration engine that decides upon where you should be running your test on based on what trigger. So that's what an orchestration engine would primarily do. You may decide to run your test maybe on maybe a mobile device platform or a cross browser platform, or you may have your own infrastructure in the cloud with Dockers where you may be running your test, but you have to actually use your resources in the right way. So it's very important to actually make sure that you're actually completing your test in the shortest amount of time using the least amount of resources. So now there are AI-based solutions which actually has intelligence to actually, what I would say, distribute your workload across your what I would say environment, and then complete the test execution at a much faster pace. So this actually helps you to, I would say, complete your regression cycles or your functional test cycles in a very short amount of time. Now, even if you have a very good parallel execution engine as well as an orchestration engine, most of the automation projects may not give you the required results, primarily because you end up, what I would say, running your scripts, and then maybe like 20 or 30% of your scripts will not be actually functional when you're running it for a formal regression cycle. One of the primary reasons due to which the scripts won't work is maybe because of the changes that has actually happened to the user interface. Maybe the developer has actually fixed the bug and they have changed the label, or you may actually have a scenario where there's a new control that has been introduced, or it can be a scenario where the properties of an object is actually modified, or maybe the control itself was actually removed. So there are a lot of scenario, a lot of, what I would say, 80% of the time the test scripts actually fail due to, I would say, like script related error. There can be also scenarios where your automation script might fail because of synchronization issues. So this may be due to maybe application behaving too slow or too fast, or either of these. Or it can be an environment related issue, which is very sporadic. It's for maybe for a second or so, your environment is not accessible. So there are like 2 to 3 ways in which you can actually solve these problems. So these are the three problems, and you can actually solve all of these using a self-healing engine. For example, if you're not able to find the property of an object, there are alternate locators that you can use. There are multiple ways in which you can recognize an object. Maybe XPath is one of the method. You actually have class, ID, and other mechanisms using which you can actually learn the properties of an object. So what you can do is, what the AI engine would actually do is, it actually looks at alternate properties that it can use in order to identify the project, identify the object. It rescans your UI, learns the object, and then try to execute this script. And if you're actually facing a synchronization issue, the tool will actually have the intelligence, or the solution will actually have the intelligence to actually go and modify the wait time so that the script actually is synchronized with your application. Or if it can be an environment not being available, you actually do have a retry engine that will actually go and find out what's happening with your environment by actually maybe waiting for some time and then triggering the automation script. So self-healing is actually a very beautiful tool. You can see up to 80% of test automation maintenance costs. Getting what I would say, it reduces your automation maintenance cost at least by 80%. You can develop your own solution if you're actually having an open source framework, or platforms like Pcloudy actually has this kind of feature now, which can be used to, what I would say, auto rectify your scripts with no effort. So what typically happens is you may actually have maybe 1,000 test cases, 20% of the script fails. Your automation team will not have time to fix them. So what happens is you start executing these 20% of scripts manually. You may not be able to achieve your deadline. Your testers will actually get stressed out because they have to complete a large number of test cases that has failed. And now after your test execution is completed manually, you have to go back and again fix your script. So it's actually a very, what I would say, there's something that happens in every release or every test cycle. And you can actually avoid this pain by actually looking at implementing something like self-healing. Now, moving on, the next use case is around coding assistants. You might have heard about coding assistants being used by developers. GitHub, Codium are some of the coding assistants that are available. You also have Amazon Whisperer. There are a number of coding assistants that are available, which are primarily, I would say, tools or enablers that will actually make a tester or a developer more productive. From a test automation standpoint, you can actually write very simple prompts that can actually help you to generate automation scripts. It can be like you providing a URL and then explaining what links to click and what actions to perform in form of a very simple English text. And these prompts can actually help you generate scripts, or it can be an API definition that you can actually provide as an input to these, I would say, coding assistants, and it actually takes those APIs and then design a set of test cases based on the endpoint. So test script development can be actually, I would say, accelerated by using solutions like coding assistants. It's not just test script development. You can actually use a coding assistant to maybe even understand the code that has been written. For example, you've been given with a framework, maybe for a tool like Playwright, and you want to understand how the framework is written. You can actually use a coding assistant to explain the code. Or if you're very new to test automation, A coding assistant can actually help you learn the test automation tool as well as the programming, what I would say, language associated with it. Most of the cases, coding assistants are used with, I would say, open source frameworks. Those are they are primarily used for, I would say, scripted kind of framework. But now there are codeless platforms also that actually has a coding assistant, which actually helps testers to generate test cases as well as fix issues in a much faster mode. There are other use cases for coding assistants as well. They can actually help you to identify the runtime errors that are caused. For example, you create a script and it is actually giving some kind of error due to a programming error or maybe due to an object recognition issue. You can actually put those errors into the coding assistant and the coding assistant will actually help you to fix the issue. Or you've written a large amount of code as part of your framework and you want to refactor as well as document it, coding assistant can be a very good choice. So there are multiple use cases for coding assistant. On an average, if you're an automation tester and if you're actually uh, involved in script development and maintenance, a coding assistant can actually save you at least 1 hour of work every day, which is almost equivalent to maybe, I would say, 20 to 22 hours of work every month. So that means like half of the weeks of work, you're actually working half a week extra, or you're actually being more productive by using a coding assistant. And these are not very costly. Some of the coding assistant comes free of cost, especially GitHub Copilot is actually available for what I would say for a very normal amount, or you can also use a free version. They're very I would say very useful tools, especially for engineers who are actually working with Playwright, Selenium, or as well as other kind of tools like Cypress. Now, let's actually take a look at the last use case, which is around test observability. You might have heard about shift left, which is actually, I would say, bringing testing to the, what I would say, to the beginning of your test cycle or agile sprint. For example, the first use case that we saw, the user story analysis or the smart user story analysis is a good example of a shift left testing technique. Testing your APIs as well as continuous regression testing are good examples of shift left. Now, test observability is about shift right. Now, many times what happens is your testers or the testers working in a bank or maybe in a financial service organization, they actually pay very little attention to what happens to your application after it has actually gone live. So there might be production tickets that are actually coming in. The end customers may be actually experiencing performance issues. The customers may not be happy with your application or the features that you've delivered in the last release. They may be actually posting nasty comments in social media. You rarely spend time in analyzing any of those. But there are a lot of ways in which you can actually improve the experience that you're providing to customers. And test observability, I would say, is one of the good practices or one of the best practices that you can implement from a shift right standpoint, where you're actually doing testing or monitoring on a production instance. So you can actually do maybe synthetic user monitoring as well as real user monitoring are two techniques that you can use or approaches that you can use for monitoring applications. So your monitoring is to make sure that your application is functioning correctly in production, and it is not just functional aspects, you can also see the response time as well as the performance of your application in production. So that's the second use case. So it's like a monitoring, what I would say, solution can actually help you to actually simulate transactions. This basically called synthetic user transactions. For example, if I'm working with a digital banking application, I may be using, maybe I may be actually performing transactions, maybe like checking account balance. I may be actually logging in. I may be making sure that the loan application page is working. So I may define transaction maybe by reusing some of the regression test packs that I might be having. And I may actually run it on the production environment to make sure that your application is functioning properly. So you may actually run scripts maybe every 1 hour and then see whether your workflows or your test scripts are actually passing and nothing is broken in production. At the same time, you'll also monitor the performance of the application. You may also see, okay, how much time did it take to complete a transaction like verifying account balance? Is it within the acceptable limits? Or is my application actually are my API calls taking a lot of time? So all of these can be actually verified using synthetic user monitoring. So there's no real user here. You're actually using an automation script to simulate actions. And that's what is the basis behind synthetic user monitoring. Now, when you're doing synthetic monitoring in the production or synthetic user testing in production, parallel to this, your real users also might be using your application. So they might be performing real transactions. So you can also monitor those transactions. And the objective here is to basically look at, again, the performance as well as the application health. And you may also find some kind of symptoms or anomalies in some of the transactions, which can be a good clue for your support team or your SRE team to go and fix the issues before it is actually getting reported by a larger user base. So real users will be actually using your application. You'll keep monitoring them, as well as you'll also have synthetic users or scripts being run parallel to this, which will also help you to measure. Maybe the type of metrics that you monitor may be very different. For example, when you're doing synthetic user monitoring, you may be looking at, I would say, things like page load time, API response time, app availability. Whereas when you're looking at real user monitoring, you might be interested in seeing error rates, throughput, maybe last contextual pain, and things like that. So there is an overlap between the metrics, but there are certain set of metrics that you specify for your RUM versus this sum. It's a very useful technique. The testing team also should get involved in this, especially around synthetic user monitoring, where they can actually reuse their automation scripts in production. There are certain precautions that you may need to make. You may actually have to use maybe certain customers, a certain set of data to test in production, or in some cases, you may have to only run scripts which are actually read-only. So the other important aspect, which I forgot to mention around user monitoring, is you may be able to simulate workloads from different parts of the world. So depending on where your application is hosted, you may be able to track your application performance. So that's another way in which is not just making sure the application is available. You can also see the response time across different countries when people are logging in. What would be the response time based on from where you're running your scripts. So, and in most of the cases, you may be running your automation scripts during synthetic user tests in a cloud environment or maybe in a platform like Pcloudy. So that's the fifth use case. So since you've covered the major, I would say the top 5 use cases, I'll hand it over to Jessica now, who's actually going to give us an overview of the AI capabilities of the Pcloudy platform. And she's also going to give us a couple of demos on some of the AI capabilities within the Pcloudy platform. Over to you, Jessica.
Thank you. Thank you so much, George, and for sharing your insights based on your vast experience, and particularly insights in the, the testing and the in the banking space. So firstly, to introduce what Pcloudy is, right? We are an AI-powered digital experience testing platform, and the core of our platform is our diverse device coverage. So we have a 5,000 plus device browser combinations, real devices that are hosted in our data centers across globally in multiple locations. So we also do support custom devices, and we also have secure deployment options, which is also something that flexibility is required, particularly in the banking space, with on-premise options, lab in a box, which is a quick to implement on-premise setup, along with a secure private cloud, which will be a dedicated tenant with dedicated devices for you 24/7, as well as a shareable public cloud. And the first layer of solution that you see here is the functional experience testing. And you'll be able to manually, as well as through automation, access our device infrastructure. You can manually go ahead and do your functional validations, run your, we support integrations with pretty much all the key frameworks, right? Like APM, Selenium, Espresso, Playwright, and so on. And we also have specialized features that are particularly relevant in the banking space, like, OCR, image injection for your check scanning or your ID scanning, along with biometric simulations and so on. And next is the performance experience testing. So this is more on understanding how your app is performing and how it could potentially be impacting the digital experience of your users, right? Something that also George was mentioning in terms of the criticality of identifying a lot of issues that are identified in production. So to preempt that and to ensure that you're running your performance experience, tests from the app level, not just on the load testing side, but in the app level, tracking all the key metrics like your UI performance, what are the page transition times, what is the time taking for your app to launch, what are the backend network API calls that are going on, are there any specific API calls that are leading to some delays or impacting the performance or the smoothness of your application, even on the UI side, like janky frames, and of course, things like, your CPU spikes, your memory, your battery consumption, your network data, and so on, as well as analysis of logs. So all of this that could be potentially impacting the smoothness of your application, the experience of your application, 60 plus metrics. So this is a key differentiator that we've been able to, bring about here at Pcloudy. And finally, on the digital experience monitoring or synthetic monitoring as well that George was referring to, where in your production application as well, you will be able to run critical workflows 24/7 and generate these similar insights and get those anomalies and performance related insights. So digital experience and synthetic monitoring is also a space that we are venturing into here at Pcloudy. And also the AI agents. Now I want to just take a minute to talk about the AI agents that are driving this, this innovation here. Firstly, in the build part of it, we have a test creation agent, which is QPilot, another key differentiator at Pcloudy, where we have been able to have a fully autonomous end-to-end agent that can create your test script and generate it. You will be able to club it as collections and run your suites across cross-platform, omni-channel. Again, that is useful for in the banking space, be it your web applications, your Android, iOS, irrespective of, the technology that your app is built on, right? As well as on the execution front, self-healing as well. So being able to fix the flakiness of your scripts, improving test maintenance, the orchestration agent as well, right? Being able to smartly allocate devices to optimize the time and your resources on which you're executing your automation. And finally, on the observability and impact analysis side, so this is more from tracking your performance of your application. How is your the AI ML based insights across different aspects to see how your application is performing. So this is to just give you a quick overview about the entire solution in our platform, the solution layers, right? And us being the forefront in the digital experience testing space. So with that, I'm just going to go ahead and, just give you a quick idea into a few key AI agents. Of course, we don't have the time to get into live demos, but of course, if you're interested, please feel free to check out all our other webinars where we've had live demos, as well as, you can reach out to us if you're interested to know more. So with that, I'm just going to go ahead and share my screen. Yeah. Firstly, we'll be looking into the self-healing feature. So basically what we're doing here, let me just set the context, is that we have two applications, a version 1 of the application based on which I'm developing a script, right? So you can see that I have the version 1 of the application here, and I'm going to run this particular sample script on a Pcloudy device, right? So we're going to first go ahead and inspect this application and see how it is, the object properties of the email, password, and sign-in, right? So for example, here you can see it's input underscore username, right? And similarly, we have developed the script accordingly with input underscore username as the ID. Similarly, for password, input underscore password, and for login, button underscore login, right? So this is how the, this is the, for the first version of our application, these are the object properties, and we have developed our script based on that, right? So now I'm going to go ahead, and execute our script, and we're going to select a Pcloudy device, and we have selected a Samsung Galaxy S22, and we're running the script. So this is just a sample APM script, and you can see in the my active sessions, the automation has gotten triggered, and we're going to get into the live view. You can see that in this case, the test step has passed. So this is expected because it's our first build, and based on which we have developed our script and our automation script, and the test case has passed. Now we're going to look into a scenario where in cases where, we have the version 2 of the application and the object property has changed, right? So we're going to look into the second build, version 2 of the application, as you can see. And we're going to go ahead and inspect the object properties of version 2 of the application. So we're going to get into the object spy mode at Pcloudy, which allows us to, get the object properties of your application. So we're getting into the object spy mode. And here you can see that instead of username, it's changed to input underscore user, right? but we're going to run with the same script that we have. And similarly, even password is changed to a different name, and similarly for login as well. So all three object properties have changed, right? And but we're going to go ahead and run the same script on the version 2 build of our application. So let's see how that works. We're now going ahead and running that. You can see that the automation has gotten triggered. We're getting into the live view. You can see that the test step has passed exactly like how it was for the first version of the build. So this, as George was mentioning, would really save in terms of your test and script maintenance, where it's able to identify that there has been an object property and it will scan for the next best object property, right? And still ensure that your test step passes. So it prevents the flakiness of your test steps and improves your maintenance, drastically improves the time taken for your script maintenance, right? That is just a quick overview on the self-healing part. Next, let me go to another feature. Yes. So next, we're going to be talking about Qpilot. So Qpilot is an agentic AI agent, which will help you autonomously generate your test scripts, right? So just to quickly, we're connecting into a device and getting into the Qpilot mode. We're selecting our application, giving the app package app activity, right? And I'm selecting the feature name, and I'm going to go ahead and give the description in plain English language, as you can see, right? There is no there is no standard format required here. You can even add validation steps, right? And you can add test data if required, if you don't want to input static data. So it is just pretty much, you don't need any coding skills. I'm just giving my natural language and I'm going ahead and giving my test steps, post which you can go ahead and save your test case and you can go ahead and execute it. So we're going to go ahead and generate the test script, and the agentic AI agents kick in, right? So we have an XPath locator where it will identify the unique XPath. So you can see each step is getting executed, ensuring high accuracy of the script. So you don't need to spend time debugging. That is the key differentiator we've been able to achieve here at Pcloudy, with the accuracy of the scripts being really high, right? You just simply need to go ahead and trigger your scripts. You don't need to spend that time debugging, right? And you can see that before the generation of each step, it executes and ensures that it's accurately functioning, post which it will generate the entire script. So now we're just going through the flow. This is a sample demo banking app in which we have created a recharge workflow. Once the test script is generated, it will redirect us to the Qpilot dashboard. And yeah, I want to quickly highlight that it works the similar way for your web application as well. You will simply connect to a browser, go ahead to the Qpilot mode, give the URL, a test description, save your test case, and it will go ahead and generate the script, right? So this is again a sample website URL that we've taken, and the test steps are getting generated, and it will reroute to the Qpilot dashboard. So it works pretty much seamlessly both for your iOS, your Android, as well as your web applications. So now we're getting into the all tests in the test collection. And we're getting into our particular script that we've generated. You can see that we have the description here, and this is the fully generated script. So it is available in multiple languages like JavaScript, Python. Java is also going to be released soon, right? You can copy and paste this into your own frameworks as well. We have test data that will be inputted here, and I can simply go ahead and run my test case individually, or I can group it into a collection over here and run it as a collection. So you can see here that I'm going to add a few cases here. We're adding multiple test cases. We're selecting the version range of devices that we wanted to execute on, saving the test case, and clicking on run. So I'm integrating this from the Pcloudy UI, but you can also integrate this with your CI/CD and run it from there as well. So post your run, you'll be able to see the live view as well as the reports and the status of each of your test case, whether it's passed or failed. And for each and every test case, you'll have the text logs, the device logs, your APM logs, as well as the app profiling with CPU and memory details with the video of the entire session, right? This is just a very quick overview of QPilot. If you want a detailed look into QPilot, you can look into our webinars exclusively on QPilot. You can reach out to us for a more detailed and live demo of QPilot. Next and lastly, I just want to quickly touch upon our app performance module, which is another key, exciting feature here at Pcloudy, where you'll be able to track the app level metrics, right? So you will simply connect to a device and right, and click on this record option here. So once you click on record, the app that you have selected will get installed, and you simply go about doing your typical user journey, right? So this, I'm showing it manually, but this same thing can be triggered through automation as well. So at this point, you're not worrying about all the data collection that's happening in the behind the scenes, right? But behind the scenes, the data collection engine is picking up on all those key metrics. But we're simply going ahead and mimicking a user journey. In this case, I'm adding an item to the cart. And once it's done, you can go ahead and release the device and get into the reports. So once you release the device, the report will be available in the report section. This is the summary section. Firstly, on the left-hand side, you'll be able to see all the relevant AI/ML insights. So in terms of the janky frames that was encountered, the memory thresholds, any large file transfers that could be hindering your performance. Right along on the right-hand side, you'll be able to see the app-related insights, like your peak CPU usage, right? Your app launch time, how much time it took for your app to launch and become interactive, right? And you can deep dive into each of these sections. So in the app insights, you'll be able to see we have a 20+ time series metrics, right? So you can see here that we have system level, app level, CPU utilization, and you can hover over any point to see the metrics of the same. And on the right-hand side, you'll be able to see what was happening at the UI level corresponding in your application as well. So the different types of memory, latency, network, transmitted and received, along with battery, voltage and temperature. And you can also hover over at any point and you'll be able to see all the metrics correlated in a single pane of view, as you can see here. Imagine trying to, correlate and get all these different metrics from different sources, right? So with Pcloudy app performance, you will simply need to mimic the user journey and you'll get all these metrics in a single pane of view. Next, we will move into the UI insights. So in the UI insights, you'll be able to see, all the frame timelines, the janky frames, and so on. You'll also be able to see the page transition. So from every page transition, right? Like for example, the home page to the login page to the home page, right? The home page to add to cart, any such options like that, right? You'll be able to see how much time, what was the duration it took for each of the page transitions. And if it exceeds more than 3 seconds, it will be marked as a slow page load, right? So you'll be able to see, and corresponding on the right-hand side, you'll be able to see what was happening in the application and which page transition took a longer time. So you'll be able to, give that feedback to your developers. And I also want to highlight that all our Pcloudy reports are easily shareable. They do not need to be Pcloudy users. Another thing that George was pointing out in terms of, things taking time with, feedbacks being delayed. These reports would really help in ensuring, that there's faster collaboration and transparency between the different teams, between your development teams and so on. And once, the next is our network page. So here you'll be able to look into every single API call that was done, the status of the API call. You can also filter out what were the slowest endpoints, the large transfers, and if there was any failed endpoints, that will also be shown here with several metrics. And you can click individually into every API and you will get all the header related information as well. So for example, you're clicking into a particular API, you'll get all the header information here. So this also can be useful in order to share with your dev teams and relevant stakeholders, right? And finally, we get into the log analysis, right? So here you'll be able to see, it will go through the entire device log. So the device logs will be downloadable here, but the log analysis engine will also go through the logs and classify it into different issues. So if there was any crash all the crash related log lines will be visible here, and you simply need to click on it, and those relevant log lines will be visible. For example, as you can see here below, right? Similarly, for the crash, it will categorize it into these relevant issues. So this is I'm just giving a overview. Again, reach out to us if you want a more deep dive, detailed demonstration of this, right? But we have 60 plus metrics. We are capturing both for Android as well as iOS, several metrics. And this is a key breakthrough that we've been able to achieve, and that's been a big differentiator here at Pcloudy. So really, if you're interested, please do reach out to me and to Pcloudy, and we'd be happy to help you get a deep dive demo of these features. So thank you so much. And with that, I'll be handing it over back for the Q&A session.
Yeah, that was a fantastic session. Thank you so much, George and Jessica. So let's jump into the Q&A segment. So if you haven't already asked your questions, you can do it now. Please drop your questions into the Q&A box at the bottom of your screen, and we'll pick that up. Here's a question for you, George. So how good is the quality of automation code that is generated by coding assistants?
Okay, so basically, if you're trying to use maybe GitHub Copilot, for example, and if you're actually writing a prompt to generate an automation script, I would say, like, for example, let's take an example of maybe generation of script, maybe using Playwright or maybe TypeScript. So the script that it generates is definitely compilable. It may not have any kind of runtime errors. And there's like a 50% chance that it may not work, primarily due to locators. In the sense, like, for example, if it's the link, if you're trying to click links on the first page, or if you're trying to interact with controls on the first page that you've actually given as the input, it works well. But if you want to actually, if your test case or the scenario that you've given actually has to navigate to a different page, which is not visible from the home page or the page that you have given, it may not be able to learn the what I would say object properties, and it may actually assume a lot of things and then it generate test case. So it's like 50% probability that the code might work, or the script may actually work or pass or fail in the right way if you're actually using coding assistant. But I would say, like, the script, even if the script fails, you may have to spend maybe 15 to 20 minutes or max of 30 minutes to fix them. If it's like a simple to medium complex kind of script. So uh, uh, so what I would like to convey is basically, like, it saves a lot of time if you're able to generate automation scripts, or at least I would say 50% of your automation script. It saves a lot of time because I would say test script development is an effort that is very effort intensive. It is the effort that you spend on writing automation scripts is almost 3 times than writing a manual test case. So it saves a lot of time. Second thing is, even if you're not a highly skilled programmer, or an automation engineer, you can still develop automation script with the help of coding assistant. So I would say the quality is not bad. I would say they are good, but you may not actually get a completely working script, but things might improve because all of these AI solutions are actually improving. So I'm hopeful that maybe by end of this year or early next year, we may reach to a state where the generated automation scripts can be directly executed without any kind of errors.
Yeah.
Okay.
Any more questions? There's one more. What are the challenges that one would face while implementing AI-based testing solutions?
Okay, so one is basically, like, I would say the cultural resistance is definitely a problem, whether it is a testing solution or a development solution or even an AI solution that is solving a business problem. So definitely there'll be a lot of resistance from within the testing team to adopt an AI-based solution, because there is always a worry about losing jobs or positions within a company. So definitely there will be a lot of resistance that you might face when you're trying to implement an AI solution. You should definitely involve your testing team in any kind of evaluation that you're doing, and also give them some challenging work. If a mundane task like maybe like test execution can be automated, or test design can be automated, there are a lot of other things that they can do which requires what I would say human thinking. So you should actually give that assurance to your testers, definitely. Second thing is most of these AI solutions will definitely require, I would say, data for training. If you're looking at maybe an execution-based solution, which looks at your historical data, you may need to train the engine. Or if you're looking at the user story engine, which is very specific to your domain or your application, you may have to actually do a lot of training. So you may need to have high volumes of data, as well as the quality of data needs to be good. So data, I would say, is very important. And many organizations do not provide data, and the quality of output that you get from these AI models will also be bad because the quality of data was not good. Third thing is basically like, don't expect results overnight. AI solutions will take some time to learn and improve. So definitely you need to give it time. So do not commit to maybe 1 or 2 weeks of implementation and then your management or leadership will start asking for results. So you may need to give it some time to learn and improve. So definitely it is not, I would say, an activity that can be very much time bound. It may slip because the AI solution may require additional training and data to improve. And even if you're looking at the fourth challenge, basically, like if you're looking at a commercial solution, you need to have a good governance model around the tool implementation. You may need to constantly look at the features that are coming inside your tool. You may need to evaluate it, provide feedback to your vendor, and then improve it. So there should be a proper review and governance mechanism that should be there. And many organizations do not have such a model. And once you implement the tool may actually improve over a period of time. There might be new capabilities, but the testing team may not be aware of any of those. So governance also a top challenge from based on my experience.
There's one more question. So how can AI be used to conduct test impact analysis?
Okay, so there are two ways in which you can actually do test impact analysis, or maybe 2 or 3 ways in which you can do test impact analysis. If you actually have access to your code base, you can definitely look at what has changed within your code and then look at what kind of test cases you need to execute. Or if you don't have access to the code, there are solutions that can actually look at methods from your binaries and then look at what are the methods the development team has actually modified, updated, or deleted. And then you may actually be able to find out what kind of test cases you may need to write newly for the newly added methods, or you may also you may be able to find out the test case that you may need to execute because your developer has actually modified or what I would say deleted some piece of or some methods from your program. So that is basically the first two methods are basically one is based on code, the other one is basically based on binary. I would say it is mostly I would say like looking at the code and or the methods and then deciding upon what needs to be executed. There's also one more method in which you can do test impact analysis, which is primarily using I would say a solution like maybe looking at the historical test runs. So you can actually look at the type of test case that are executed in the past, what kind of defects were uncovered, how long did it take to run. So a lot of metrics data can be collected from your previous data or historical runs. And this data can be used in order to decide upon what type of test cases or what test cases you may need to execute for a new build. So this is a completely AI-driven solution with a lot of training that might be required to actually train your engine based on your historical runs. And these kind of solutions will actually help you to save a lot of time with respect to executing your test. So you may be executing a low volume of test cases, but these low volume of test cases might be good enough to find majority of your defects. So these are the three types of solutions that I've come across for test impact analysis.
Right.
Okay.
I don't think there are more questions, and we are already running out of time. So that brings us to the end of today's session. And a big thank you to our speaker, George, for sharing such valuable insights, and to all of you who joined us today for being an engaged and interactive audience. And if you have more questions and if we couldn't answer it, please don't worry. You can always reach out to us at info@pcloudy.com or connect with us over LinkedIn. And also, as a quick reminder, this session is being recorded, so we'll share the link with you soon after the webinar, and feel free to revisit the discussion or share it with your colleagues as well. So stay tuned for our upcoming webinars, and be sure to follow us on LinkedIn for more updates on AI-driven testing, automation, and industry best practices. So until next time, happy testing and have a great day. Thank you.
Thank you.
Thank you.